Hello and welcome to this video. In this video we're going to be looking at the laws of indices. Okay, so when I say indice or index would be singular, it just means when I have some power, right? So if I have maybe x to the power of 2, this is known as its index. Okay, so it has an index of 2, or the laws of indices, meaning we have plural. So if we know we can add together things that have these indices. So if we had maybe an x squared plus an x squared, this would just become 2x squared because we have 2 x squareds. If we had maybe 3x squared minus 2x squared, this is just going to become x squared because we're just getting rid of 2 of these 3x squareds. But adding and minusing isn't always what we want to do. Sometimes we might want to multiply things together. And so if I had x to the power of maybe a, so I'm going to keep this in letters to make sure it's general, and then we'll give you some examples in a second. So this is going to be the first law of indices. If I had x to the power of a multiplied by x to the power of b, notice x is the same number, but a and b change, it becomes x to the power of a plus b. Okay, so this is your first law here. And what this means is that if I were to say maybe x to the power of 3 times x squared, this is going to give me x to the power of 5. Okay, so I can just add together these two numbers at the top here, and that's going to give me the resultant power of the third one. Now, along with multiplying, we might also be asked sometimes to divide. So our second one is what happens if we have x to the power of a divided by x to the power of b. And we can kind of see that if multiplication and division are opposites, when we multiply, we add these two. So when we divide, we're going to minus these two. So it becomes x to the power of a minus b. So if we had, for example, let's go with the same thing. If we had x cubed divided by x squared, this would just give us 3 minus the 2. This is just going to give you x to the power of 1, but we don't have to draw the power of 1. And that is our second law. These divisions can also be sometimes written as just fractions, so they could have also written this as x cubed over x squared is equal to x to the power of 1. That would have been equally as valid. But what happens if we have something, so let's say we had like 3 to the power of, well, let's go with 2 to make it a little bit more obvious. So let's say we had 2 to the power of 1. Well, we know 2 to the power of 1 is just 2. 2 to the power of 2 is going to be 2 times 2. 2 to the power of 3 is going to be 2 times 2 times 2, which is going to be 8. 2 to the power of 4 is going to be 2 times by itself 4 times, that's going to be 16, and so on. But what if I wanted to go backwards? What if I had 2 to the power of 0? What would that be? Because we know this law of indices, if I have something squared, it means that's x times x. If I have something cubed, it means that's x times x times x. And so if I have something to the power of 0, it means that I'm not multiplying it by itself any time. And so this is our third law, and this is that if we ever have anything, any number to the power of 0, it is always going to equal to 1. Okay, so no matter what it is, it could be 375,270,332 to the power of 0, that's equal to 1. Okay. Now, what if we wanted to go even further than that? So we've said that if we go backwards and we go to 2 to the power of 0, we get 1. What happens if we wanted to go 2 to the power of minus 1? So 2 to the power of minus 1, what would that be? What about 2 to the power of minus 2? What would that be? 2 to the power of minus 3? What are these things going to equal? And so this is going to be our fourth law. So if we keep going backwards, we're essentially saying that to go backwards each time. So if I make this list again to make this seem more explicit. So if I have 2 to the power of 0 in the middle, I know that's equal to 1. 2 to the power of 1 is equal to 2. 2 to the power of 2 is equal to 4. 2 to the power of 3 is equal to 8, and so on. Okay? Notice every time I go up here, I'm multiplying both sides by 2. So this becomes times 2 again. This becomes times 2 to what is down here. So if I want to go down 1, instead, if I want to keep going down, I'm going to divide by 2. And so this is going to give me 2 to the power of minus 1 is equal to 1 over 2. Okay? Now, what this means in general terms is if we had x to the power of minus 1, it becomes 1 over x. Okay? This is another law that we have. If I wanted to go again, I would have to divide this by 2 again, and that would become 2 to the power of minus 2 is 1 over 4. Then 2 to the power of minus 3 is going to be 1 over 8. And so really, I could either make this in terms of this formula or a second law, but I'm just going to alter this law slightly. And if we realize that any number that's here, this is 2 to the power of 1, this is 2 to the power of 2, this one, 8 is 2 to the power of 3, so really, x to the power of minus a becomes 1 over x to the power of a. And this is our fourth law. And fifth, we're going to have to step away from this for a second, but if we're going in full integers, we have 0 to 1. What if we wanted to have 2 to the power of a half? What are the powers? And so if I had x to the power of a half, that is the same as the square root of x. Okay, so that's the square root of x. Okay, if I had x to the power of a third, it would be the cube root of x, and you get the idea. You could keep going with this. Now, what if I had x to the power of 2 over 3? Well, I know the third part of this is going to be 1/3, or is going to be the cube root of x. But what happens to this 2? Well, that's going to be this squared. Okay? And the reason is we can actually split these into a bracket. I could split this power into saying this is x to the power of 1/3 times 2. Okay? But how would I multiply powers? We know we can add powers and we can minus powers, but how would I multiply them? And that is going to be the sixth law. So the sixth law, so I should label this to be the fifth law, but it could also stretch out to being the cubes, or maybe even the 2 over 3s would be the cubes squared. The fifth law says that if I have x to the power of, the sixth law even, x to the power of a with brackets and b on the outside, then this becomes x to the power of a times b. Okay, so this is how we're getting this idea here that we can do this, because I could just split it to be, I could write this as x to the power of a third all squared. Okay, and that would be the same as writing x to the power of 2 over 3, which would be the same as writing the cube root of x all squared. Okay, so these are the laws of indices. There's not really much way to explain any more than this how they work. They're really just kind of something you have to know and be able to memorize, really, and be able to apply to solve some practice questions. So we're going to apply some of the laws of indices that we've looked at in the revision video and hopefully be able to answer all of these questions. So our first question is to write these numbers in order of size, starting with the smallest number. So the best thing to do is to work out what are all of these numbers first of all. So 0.5 is 0.5, minus 5 is minus 5. But what would 5 to the minus 1 be equal to? If you remember from the revision video, if we have anything to the power of minus 1, it becomes 1 over that number. And this would become 1 over 5. And 1 over 5 is just 0.2. So I'm just going to write this here. This is equal to 0.2. This is 0.5. This is minus 5. And if you also remember, x to the power of 0 gives you 1. No matter what number it is, this is always equal to 1. So now if we wanted to write these in order, minus 5 is the smallest, and so we start with minus 5. Then 0.2 is the second smallest, but remember we have to write it how they've given it in the question. So that's going to be 5 to the minus 1. Then 0.5, and then 1 is the biggest, and so that's going to be 5 to the power of 0. So this is our answer to this first question. Now the second question, we've been given 3 different things that they want us to simplify. So now this first part A is going to use the law that x to the power of A multiplied by x to the power of B is going to equal x to the power of A plus B. So in this case, A and B are 7 and 3, so we're going to get x to the power of 7 plus 3, which is x to the power of 10. Now the second question is going to use this formula where x to the power of A all to the power of B is the same as x to the power of A times B, where in this case A and B are 4 and 3, so this is going to be m to the power of 4 times 3, which is m to the power of 12. And now this third one here is going to be a little bit more complicated, but we're going to use the same thing for all 3 of these variables. So we have a variable of having numbers, then having a's, and then having f's, but we're dividing everything. And if you remember, x to the power of a divided by x to the power of b is equal to x to the power of a minus b. And so 36 divided by 12 is just 3, so we can write a 3 at the start. If we have a to the power of 1, which is this a up here, divided by a to the power of 5, it becomes 1 minus 5, which is a to the power of minus 4. And then if we have f to the power of 8 divided by f to the power of 2, 8 minus 2 is going to give you 6, so this is going to be f to the power of 6, and that is your simplified version of that formula. Okay, now find the value of 2 to the power of minus 3. So if you remember, we generalized this. We said that x to the power of minus a is equal to 1 over x to the power of a. So in this case, this is 2 to the power of minus 3 is equal to 1 over 2 to the power of 3. And 2 to the power of 3 is 8, so this is just going to be 1 over 8. And if you wanted to, this is 0.125, if you wanted to put it in a decimal form. Either of these forms is completely fine. Okay, so now this last one is a little bit tricky. So we're saying 5 times root 5 can be written in the form 5 to the power of k, and they want us to work out what is the value of k. So first of all, I want to put this all in the same, under the same square root. And now if I start with 5 root 5, I know that if I wanted to get this, 5 is equal to the square root of 25. So I could rewrite this as root 25 times root 5, and then I could put these together and say this is the same as root of 125. Now, if I had this, it would be useful to know at this point that 125 is a multiple of 5. And actually, 125 is 5 cubed. So I could say that this is 125 is equal to 5 cubed, and therefore this is equal to 5 cubed square rooted. But we know from this law of indices that if I have the square root of x, I could write it as x to the power of a half. If I have the square root of this becomes 5 to the square root becomes 1 over 2, but this is all cubed then, so this becomes 3 over 2. So if you were to type in 5 to the power of 3 over 2 in your calculator, it will give you out 5 root 5. And so the value of k that we have is that k is equal to 3 over 2. Okay, and now the final question is probably going to be the most difficult one that we'll look at. The first part is to simplify fully 3e all to the power of 0. Now we said anything to the power of 0, x to the power of 0 is always equal to 1, so this is just 1. That one's nice and easy. However, this one, we've got a lot going on here, so I'm going to write it out a little bit bigger. So 64x to the 6 divided by 25y squared, all to the power of minus 1 over 2. This is going to involve a lot of laws of indices. First of all, we have something that is negative. We said x to the minus a is equal to 1 over x to the a. We also have something that's a fraction. We said x to the power of, let's generalize it. We said x to the power of a half earlier in this video is root of x. And we're going to use the divisions as well, although they're not really going to be needed too much for the algebraic, but we are going to divide the 64 and 25. So I would say first thing is get rid of this minus sign here. And in order to do that, we're just going to put this 1 over this, which is the reciprocal of this. So we're essentially flipping this fraction around. So that's going to then become 25y squared over 64x to the 6 all to the power of a half, getting rid of that minus sign. Now, all to the power of a half means we're square rooting everything inside of here. And if we were to square root 25, we get 5. The square root of y squared is y. The square root of 64 is 8. And x to the power of 6 square rooted is the same as saying x to the 6 all square rooted. That could become x to the 6 over 2. And that 6 over 2 can just simplify to x cubed. So this is our simplified formula. We can't simplify it any further than this. And so this is what we want to write on the answer line, that 5y over 8x cubed. Okay, so these are the laws of indices. Hopefully the way we've worked everything out is all okay. Thank you for watching.